So here's another example. This is the third example, and what we'll do is we'll just kind of use our work up here. We know ax squared plus bx plus c equals 0. The solution is given by the quadratic formula, so I'm just going to find out what a is. So what is a? It looks like a equals what? 4. Looks like b equals -4. And looks like c equals 1. So then I'll just write the shell of my quadratic equation. X equals minus b. You should always write this out. Plus or minus the square root of b squared minus 4ac all over 2a. And I'll just substitute those values in. So b is -4, b is -4, a is 4, and c is 1. All right. And a negative times a negative is positive, so I got 4 plus or minus the square root. And -4 squared is 16. Minus 4 times 4 is 16. Now this is interesting. All over 8. And notice, under the radical, it's 0. So that's the plus or minus part, so I just end up with x equals 4 over 8. This is 0. So x equals 1/2. Oops, sorry about that. Start here. Okay, so what does that mean? Well, that means I've got one root. Now, in the other cases, the other examples we had, notice we had two roots. Okay, here we had two real roots. We could see them. Here we had two complex roots. We couldn't see them. And now we have one. So if I was going to graph this, what's it going to look like if I've got one root? 1, 0, or one time it touches the x-axis. Well, I kind of answered my question there, didn't I? So x equals 1/2, so I can find that. I know it's going to touch the axis because that's the 0. That's where the value is equal to 0. So if this is 1, so this would be 1/2. That's my 0. And I know it's shaped like a U because this is positive, so it's going to be like this. It's going to be a problem. I don't know how. It's going to be a little skinnier because there's a 4 in front. But. So something like that. So that's the solution. Well, that's kind of the graph of the parabola. And the 0 is actually just x equals 1/2. That's where it crosses the axis. And that kind of makes, so that covers all the possibilities. In other words, if you've got a parabola shaped like a U, it can either cross the axis in two places, or it could not cross the axis at all, be up like this, or it can touch in one place. Now, these all have to do with what's under the radical. If this is 0, we have one root, or one solution. If this is a negative under the radical, we have an I, so we have no real roots. We have two complex roots. And if this is positive under the radical, like here, we've got two real roots. So that leads us to the concept or the idea of the discriminant. All right? I guess I can write that over here. The discriminant is just the part that's under the radical, and that's b squared minus 4ac. Oops, sorry, you can see that. All right. B squared minus 4ac. Now, if that was positive, or greater than 0, what did we have? Well, like in this case, you can see our discriminant. What was under the radical was positive. So we had 2 real roots or solutions. Now, if b squared minus 4ac, again, that was what is under the radical. Okay, that's this part over here. In this case, this was the b squared minus 4ac, b squared minus 4ac. If that's negative, we had 2 complex roots. And sometimes we say complex imaginary because we did have an imaginary part, an I in there. Imaginary roots. Because in reality, all numbers are complex numbers. The imaginary part is 0. So we have 2 complex roots. That I would hope would suffice. And then what happens if that's 0? Then we have 1 real root. That was our last example. That was this one where x was equal to 1/2. So we have 1 real root. So you can just look at the discriminant, and sometimes they just ask you to look at the discriminant and describe the roots. So all you have to do is calculate b squared minus 4ac. If you get a positive number, you've got 2 real roots. If you get a negative number, you have 2 complex roots or complex imaginary roots. And if you get 0, you have 1 real root. And we showed you the examples there. So I hope that makes sense. So that's the discriminant, b squared minus 4ac. Just that part of the quadratic. Again, it's just this part, the b squared minus 4ac, the part that's under the radical of the quadratic formula.